Well, hello again. I'm glad you came back and watched another video. These are so much fun. Alright, so today we're going to continue with probability. Today we're going to talk about the probability of multiple events. That means instead of knowing what are the chances of you flipping a tail on one flip, now we're talking about multiple. So like what are the chances of flipping two tails in a row on a coin would be an example of a multiple event. So we have two different things, or the same thing essentially happening more than once. Alright, now there's two different possibilities. We have independent and dependent events. So independent events, sometimes called with replacement, and I'll explain that in a little bit. It says the outcome of one event does not affect the outcome of the second event, like flipping a coin. If you flip a head on the first coin, in the second flip, it's not going to matter. So you've started over. That's the idea of with replacement, is you're starting over from the beginning. The first event has no effect on the outcome of the second event. Alright, so when that happens, we want to find the probability of A and B. So again, the probability of flipping two tails in a row, so I'm talking probability of getting a tails and another tails, is the probability of event A happening times the probability of event B happening. Right, and again, we'll be using those decimals, so you definitely want a calculator for some of this work. Alright, now the second option, what are called dependent events. That's without replacement. That is where the outcome of the first of one event, that's spelled wrong, one event, does affect the outcome of the second event. Alright, sometimes again that's called without replacement. So for example, you have, 12 sweatshirts in your closet, and you want to know what the chances that you pick two in a row that are, both blue. And so when you pick the first one, you're not going to put it back into the closet before you pick the second one, because then you could pick the same shirt twice, and that wouldn't really be two shirts. So you'd pick the first shirt, and you'd pull it out, and then you'd pick a second shirt, but again, you didn't replace the first one back in, so that second event is a little bit different. So for example, like I was saying, let's say you had 12 shirts, and you're trying to pick out two blue ones in a row. So again, that first one, you'd be the probability of A would be your probability of picking out blue shirts. Let's say you got 4. 4 of the 12 are blue. Well, when you go to pick out choice B, you've already picked one of the blue shirts, meaning that there aren't 4 blue shirts there anymore. There's only 3. And there aren't 12 shirts in the closet anymore. Now there's only 11. So again, the events are dependent on each other. That second event depends on what happened in the first event. There wasn't a replacement. We've continued to move forward without putting the original one back in. Now, obviously, that's not the same as flipping a coin. So that's why these, again, have a little bit different procedures. So let's do one of each. Let's say I can spell properly. And suppose a number cube, which is a die if it's 1, or dice means plural. That would be 2 or more. But again, a number cube. So I'm going to assume that it's got 6 numbers on it. It's rolled twice. What's the probability of rolling 2 odd numbers? So again, it would look like this. I want to know the probability of getting an odd number and another odd number. All right, so let's look at it. So the first one, let's call this A, and then this would be B. So let's do the probability of A, the probability of rolling that first odd number. All right, and then we're going to times it by the probability of B, which is that second odd number. All right, so let's figure out. First one, we're going to roll this dice. Now, our chances of getting an odd number, well, a dice has 6 numbers. 1, 2, 3, 4, 5, and 6. And the odd ones are 1, 3, and 5. So there are 3 out of a total 6 possible odd numbers. Now, on the second roll, does the first roll have any effect on the second roll? If you get a 1 on the first roll, can you get a 1 on the second roll? Is that allowed? Or you're not allowed to get another 1 again? Well, that second roll should be independent. It should have nothing to do with the first one. So that second roll would be another 3 out of 6. So you get a 50% chance at each of them. So when I multiply those together across my numerator, 3 times 3 is 9, and my denominator, 6 times 6 is 36. And again, you don't have to worry about reducing fractions or anything like that, because we want a decimal answer in the end. I'm just going to do 9 divided by 36, and my final answer would be 0.25. A 25% chance that if I roll a die and then roll it again, that same die, roll it all over again, that I'm going to get another odd number. So 25% chance of getting 2 odd numbers in a row. Okay, let's try another one. A class has 10 girls and 15 boys. they need to select a president and a vice president. What's the probability that 2 girls will be selected? So once again, we're looking at the probability of getting a girl as president and getting a girl as vice president. So let's look at the first one, the probability of getting a girl as president. That'd be our first one. That's kind of our A, our president, and then there's our B. So our probability of getting a girl as the president, and then I'm going to times it by the probability of getting a girl as the vice president. All right? But in this one, can somebody be both at the same time? Can I pick someone to be the president and then that same person is also the vice president? The answer would be no, I cannot. So this would be one that's dependent. So again, I've got this group of girls. At the first one, there are 25 kids in class and there's 10 girls. Could be any of those 10 girls that's picked as president. But when I go to pick the second person, I can't pick that president. So let's say, whoever it is, Autumn, you're president. So then that means that there's only 9 girls left to choose from, and there's only 24 people left in the class, because again, that first person can't be both. Can't have a repeat, so no repeats allowed. All right, and again, I'm going to go ahead and use my calculator to do some of this work. That 10 times 9 is easy, and 25 times 24 for my denominator. And then again, my final answer, I'm going to go ahead and just divide those numbers, and I got 0.25. So there's my answer to that one. There's a 25% chance that I pick 2 girls. All right, so again, the key here is understanding if the events are independent or not. And most of the time, it's kind of straightforward. But if there's any tricky ones or any trouble like that, I'm on the Zoom. You can join in and ask me for help or ask me to just clarify an answer. If you need anything else, again, you know where to find me. And good luck today.